they met with certain set of equations, they always found solution in the set of real numbers. But there was another equation like this, x square plus 1, or we can write x square is equal to minus 1, or we can say that in fact there is certain number which may be called the solution of this equation, right? So there is no number in the set of real numbers which can be considered as a solution of this equation. For example, if you take 1, its square is 1. If you take minus 1, its square is again plus 1. So there was a problem to solve this equation. To find the solution of this equation, the scientists, the mathematicians try to think about this, that there must be a solution of this equation. So after means many efforts, they come across the idea that there is some number which can be termed as imaginary number. Iota is the imaginary number. There is a number, we cannot see it, but there is certain numbers that whenever we scale it, it gives us minus 1. So after that, they come across a certain number known as imaginary number, and then the theory develops after invention of this iota, how we can represent this number. For example, we can represent real numbers with this real line. Then there was a problem how we can represent this number geometrically. So the things developed step by step. Then after that, they try to associate many other things. For example, limits of a number, limits of certain function. Function is now function of complex variable rather than its real variable. So how we can find the limits of that function, then how we can define the continuity of that function which is depending upon complex number, then how we can define the differentiability of that complex function, and similarly how we can represent the series representation, and all the things which we study in real analysis. We try to associate all those things here in this subject. Okay? Differentiability, continuity, then uniform continuity, and then how, for example, in real analysis we have this type of integral, and instead of this, if we have f of z, means the function depending upon the z variable, then how we can integrate this function, how we can differentiate this function, how we can represent this function in terms of Taylor series or some other series, and similarly other things associated with this type of function. We will try to study all these things over. So this is just a review, we can say, of the things we will study in this course. Another interesting application is, it's very useful in finding the, for example, the engineer always come across the Fourier transform, Laplace transform, and their inverses as well. For example, if we have certain function f of x or f of t, then Laplace transform is nothing but this function is multiplied with this function, and then it is integrated from 0 to infinity over the variable x. what is left over there is a function of s. Okay, so this is called Laplace transform of these functions. So we also need to find its inverse as well. So the inverse is defined as 1 over 2 pi iota integral gamma minus iota infinity to gamma plus iota infinity f of s exponential plus sx ds. So this is the inverse Laplace transform of this function. This is a little bit easy integral, whereas this integral is not so easy. Okay, but we will see at the end